Yeah, hello and welcome back to the Developer's Guide to Windows 10 brackets build 10 through 40 close brackets. I'm Andy Wigley and this is...
Hi, I'm Shen Chauhan.
Right, we're going to talk about... We did a session just now, well, before lunch for us, on adaptive UI, and we're now going to talk about a related subject, which is adaptive code. So, adaptive code...
Slight difference
well,
there,
right? It is. It's the only...
Yeah.
Actually, the commonality is the word adaptive there.
Yeah.
But other than that, different topic.
Yeah.
So what is it all about? So, well, what is this all about? It's all about, this is about selectively calling APIs on different platforms. So before we were talking about adaptive UI as being how do you create a UI that looks great on different screens.
Yep.
Well, this is, okay, I know that the majority of the stuff I want to call is in the UWP SDK. And that's going to be true for, I mean, I think I heard statistics being banded around from engineering that they were aiming at sort of 86% of all the calls you're going to want to make. That's very precise. No, that was
86.54.
Yeah, that's right. But anyway, a high percentage of all the APIs you're going to want to use in a typical app
Yes.
are going to be found in the UWP. But there are a few cases here and there where there are specific APIs that do specific things on specific platforms, and how do you take advantage of that? But then not lose this nice one binary, one app package story that we've got, and one store and all the rest of it. So that's what this is about. So, you know, an adaptive app, it's like I say, we're talking about adaptive UI being different screens, but then adaptive code is about lighting up your app. So, you know, conditionally executing stuff when running on these, and it's about, there's two aspects to this. First of all, okay, use an API that's only available on one particular device. One example of that would be what?
An API. So maybe like the brightness control on the desktop or the GPIO controller, maybe?
GPIO controller is a great one on Raspberry Pi. Yeah, that's something that you're just not going to have on the other device families, but it's pretty fundamental to create an app for those devices. So yeah, so that's about taking advantage of unique device capabilities. The other sort of subtler aspect of this as well is talking about the way as the platform evolves and new versions of APIs get rolled out. You know, you could ship a whole package and declare a hard dependency on a certain level of the API set.
Yeah.
Or you could say, okay, I'm just going to keep my one package, but I'm going to have it adapt to offering up-level capabilities on systems that have already been updated to the latest version N of whatever API, but also keep working on those that haven't quite been updated yet. And although we are talking about a very fast refresh cycle for end-user client devices, especially if you're targeting enterprise, there's going to be a bit more of the potential for your app running on slightly different versions of the platform. So these patterns we're going to talk about here help you manage those situations. So first of all, let's talk about not conditional code, but kind of, it's a related thing. It's important to understand what we're talking about. And if you look at a Windows 8.1 universal app, we still do have, you're still targeting those.
Yeah.
So last year, what are you doing? You're still doing that stuff. Come on. So we actually tend to have a shared project where you have all the common code.
That's right.
And then you have a Windows desktop head, and then you have a Windows phone head.
Yeah.
And when you compile that, you actually end up with two binaries and two app packages. So the idea here is you can share a high percentage of your code, but you end up with two binaries. And the way that's selected, the API set, although we call them Windows 8.1 Universal Apps, there were a few subtle changes in the API set.
Yes.
Some changes here and there, but it was pretty broadly aligned. It was pretty close. And you had some differences. And so how did you handle those differences? Well, in that case, you would tend to use compiler conditionals,
Yeah.
So what you're doing with this is, with this pound-if, hash if. I don't know if it's pound-if.
Hash. I use hash, but I don't know.
Yeah. If you're over here, when I was with Jerry Nixon, he was always talking about pound.
Pound, yeah.
But for us Brits, it's hash if. Yeah. So, but anyway, that's defined. That conditional is defined in the project properties.
Yes.
And what it means is that when it's compiled for phone, this bit of code's going to be included, but when it's compiled for desktop, it's not.
Correct.
So this is selecting code at the compilation stage, which is not what we're about.
No.
With UWP. So we've only got one project with a UWP. So you can't set compiler conditionals that apply to this device family but not to
No,
this
because
device family.
that just wouldn't work, right?
No, that wouldn't work.
Yeah.
So it's slightly different in UWP. It's actually the switch moves from, instead of selecting at compile time, we're selecting at runtime.
Yes.
So this is kind of what it's about. So here's a block diagram of broadly of our families. We've got the Windows Universal Platform, and underneath that we've got different device families: desktop, PC, mobile, blah, 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 all the way through to HoloLens, well, holographic device family. And then the green ones are specific products, if you like, that are in those device families. And all of these are essentially, they're all built on Windows Universal. This is where the mass of your APIs are going to come from, and it's all common across all these platforms. This is the power of the UWP platform that we're talking about. So UWP is this single API surface guaranteed across all these devices, and this is where you're going to find most of what you need. So yeah, just to keep stressing this, in the majority of cases, you probably ain't going to need any extension SDKs, but
No.
you don't want to, you don't want it to be
Never say
constrained.
never.
No,
Yeah.
never say never. So when you do want to sort of do something a little bit, in the first session I showed a demo where there's the media capture APIs are in the UWP. So you can do a full camera capture kind of application just using UWP APIs. But there's this one little edge case, if you like, the camera options UI, which just allows you to change brightness and whatever.
Contrast and things like that, yeah.
And this pops up a little window, some UI that allows the user to select that. That is only in the desktop extension SDK, not available on other platforms. So we want to have a system where we can make use of that on desktop. So for those that do, we have these extension SDKs, and for them you just add ref like that, and down in that list of SDKs you will find...
Under the extension.
Under extensions, yeah. You drill down to Universal Windows extensions, and there's a whole bunch of them. Reading up from the bottom, it would be a bit small for people watching on. But it's from the bottom, Windows Team extensions. That's the Surface Up.
Surface Up, yep.
Windows Mobile extensions is for phones, small tablets. Windows IoT extensions.
Things like the Pi.
Raspberry Pi. And then the one that's highlighted is Windows Desktop extensions. And then above that we've got stuff like Test and SQLite
like
and
C++ runtimes and things like that.
Stuff like that. So you've got these different extension SDKs, you just add ref and then you can make use of them. So the important thing to stress here is if you do add a reference to the desktop extension SDK, you're definitely not immediately saying, okay, this app now can only run on desktop. That's
you're not targeting, just for that particular platform at that point. You're just saying, hey, there's an option to enroll this app onto that platform by lighting it up using this SDK.
That's right, that's right. So yeah, we allow it to light up, and the way we light it up is we make a call at runtime using this API.
Is type present.
Is type present. That's the main one. That's why it's highlighted. But actually, you can see there's a bunch of other methods on there which are less generally useful, but still going to be useful in some circumstances. So you can figure out if a particular method is present, an event, a property, a read-only property. But basically, you're checking. For the most part, you're checking for types.
Type.
But you can do much more fine-grained kind of detection with this API. So that's good. We can do that. And the pattern is kind of like this. The one downside of this, I think, is the Windows Foundation metadata API information is type present. The argument to that is a string.
String, yeah.
But then, presumably, when you test this, you're soon going to find out if you spelt the string right.
Yes, true.
And you're testing thoroughly, of course. So that's the way it works. And then, if that is true, then this bit of code will be executed. And if it's not true, which will happen on other device families, then it just won't get executed.
It won't get executed, yeah. So it's similar to like a compiler condition, but obviously done at runtime.
Yeah, that's exactly right. Yeah. So that's what it is. The API information tests for availability of a type or contract, or as you saw, method, event, all the rest of it at runtime. Now, that pattern is slightly tedious to write, perhaps. Yeah. Although, if you're clever, you'll have a snippet to do it. Yeah. But there's actually a better thing now, that there is a NuGet package, the platform-specific.analyzer, which you can add that to your project, and it will check. It will go through all your code, and IntelliSense, in a way, will check for any calls to APIs that are in extension SDKs.
Oh, right.
And it will it will give you a warning, a UWP001 platform specific code, give you a warning if you've made a call and you haven't gated it with the calls to this API.
Okay, and then it wraps it.
And then, then the good news is it will actually go ahead and add that code for you straight away.
So this might be using some of the Roslyn APIs or something.
It will be using the Roslyn APIs, yes.
That's
so
cool.
It's cool and it's clever stuff. It probably should be in the product.
Yes.
I did say that. Yeah, but there you go. It's a NuGet package, so you can add this. I highly recommend you do. Lucian Wishick is responsible for this. Yeah, clever guy. Finding out if you've got an API you want to use, finding out if it's in an extension SDK or not.
MSDN.
Yes, it's not, perhaps, it can be a bit, you've got to go drilling down into the docs really. And if you look at the docs for your class and then, of course, what you'll do is you'll call it, and then when you run the NuGet package, and it will highlight the fact that this is. I suppose that will only work if you've added the extension SDK. So if you haven't added it, if you haven't added the extension SDK, it wouldn't compile. So Visual Studio straight up will tell you, this doesn't resolve. So then you probably would say, I don't get that. So you go and look in MSDN, and then you'll drill down and you'll find the requirements. It'll tell you which device family it's in. So that's effectively saying
mobile. Yeah.
You need the mobile device family extension SDK. So that's kind of the way that your work processes will go with this. You can also drill down into Object Browser, and once you've added an extension SDK, you can go and drill down. It's not quite as simple as this, because the Windows.phone contract is one of the contracts in the phone extension SDK. Yeah. It's the main one. But the desktop extension SDK has got a kind of a few more. So you can go exploring here anyway and drill down and find out exactly which APIs are in the contract. In actual fact, if you want to find out which contracts are in extension SDK, what you have to do is go to your programs x86 Windows Kits.
Yeah.
Windows Kits. Let's actually do this.
Yeah.
Let's go down. So you go to.
And then it's
we go down to
C
program files x86
Windows Kits
Kits, there it is.
And then 10
extension SDKs,
correct, and then they're the ones you've got installed.
Let's pick Windows Mobile.
Then
there's the version, and actually as new versions will be released, they'll
side
by side. So
at
the moment we've got 10.0, 10.2.40, and here's this SDK manifest. So let's open that with Notepad. Okay, there you go. Those are the API contracts inside the phone.
And you can see the phone contract we were looking at earlier.
Yeah, there's the phone contract one. But as you can see, there's a whole bunch of others.
Yeah.
And the other thing to say about this is these contracts, and you can, like I said, you can drill down in Object Browser, probably have a look at what exactly the APIs are in it. But these contracts, these API contracts, are not exclusive to this extension SDK. So
they could be in other ones as well.
They could be in others as well. Yeah, you could get a case where there's a certain API is not in the UWP, but it's in both the desktop extension SDK and the mobile extension SDK.
Okay,
that can happen.
That's good to know.
That can happen. So there you go. That was that. Little bit of kind of exploring to go and see exactly what's.
And again, the min version you set on this particular project will also then state what extension SDK will be made available, I take it.
Yeah, that's right. Yeah. So, right, little demo. Oh, I should have stayed where I was. Let's go back to the other desktop. Here we go. So I've got an app here which is kind of interesting. So. This is an app that I built for Windows Phone before, because it's exploring the effective pixel size of a view and also playing a little bit with the transparency of app bars and the status bar. So one of the APIs that's in the phone contract is the one that allows you to get at the status bar, which is obviously the strip across the top of your screen where the icons
battery
are.
Battery and cell reception.
Exactly, reception strength and that sort of thing. And maybe in certain apps, you might want to hide that. Think twice about that. Most users like to see that kind of information, but maybe you've got a case for it. So in order to do that, here you might do something like this. You say, okay, I'm going to call windows.ui.viewmanagement.statusbar, which I know because I happen to know is the API for doing that. Get for current view, hide async.
Okay.
And this line of code would have worked just great in a Windows Phone 8.1 application. But as you can see here, we've got a red squiggle on this. That's because it says here...
It's an extension.
Yeah. Type status bar could not be found in the namespace windows.ui.viewmanagement. It's done some weird... ignore all that type forwarding to assembly stuff. The real reason why I can't find it is because I haven't got the mobile extension SDK referenced. I've got the desktop extension. So we can go off in here and we can add reference. Drill down under here to extensions.
Yeah.
Off down here, and we check the mobile and we add that. And in a minute, IntelliSense says, yeah, I'm good with that. So that's great. Got no compilation problems, no squiggles and that sort of thing. We're all good. So we can run this on the phone.
Yeah.
And it should work just great. And on our app, the status bar should have disappeared.
So you can see currently it's there with the battery and the
yeah, that's the bit at the top there.
Yeah,
the screen,
and that should hopefully go.
And
there we go.
And it's gone. Yeah, and actually this app you can kind of, you can actually show it and hide it.
I can see, yeah, you can.
Yeah, so we'll play with that in a minute. Now, before we do, that's fine. As that jump down, there you go. Now let's run it on the desktop. Remember, this is one app package. It all compiles. It's all good. This sort of thing. Run it on the desktop. Here we go. We're running it. Same. Does a build. Not that it had anything to do. Nothing's changed. And here we go. And what will actually happen at this point is we're trying to run the same app on here. This is what happens.
Exception.
Type load exception, because that type's not available.
That's because we didn't do the type check, right?
We didn't do the type check.
Yeah.
Yeah. So this is where we can. You could either hard code that gating code, or because I'm lazy, or I like to use tools, I'm going to go off to NuGet and install the platform specific .analyzer package.
That's the one.
Install it.
So this is going to add it in your project.json as well, isn't it?
Yes. Yeah, that's right.
Project.
So this is now it's now in my NuGet packages. So that the wizard adds it in. So actually down in my project.json. Yeah, we've got. Oh, it doesn't. Maybe.
Yes.
Oh, yes, it does. There you go. Yeah, platform specific .analyzer has been added in, which is good. Now, here's an interesting thing. You see now, straight away, since I've done that, we've now got a green, which is the kind of thing you normally get for, improvements and.
Yeah, it's like a.
Yeah, it's a warning.
Have a look
kind of
at
thing.
this.
And then this is a warning. Platform specific code show potential fixes. And I think actually, if I'm right in saying. The last time I looked at this, you can actually change the. Is it properties, or do you have to drill down? No, maybe drill down a bit further. Oh, you can set the rule severity.
Right.
So it's just default. You can actually set it as
It's kind of cool. So you could actually have it give a compilation error, so when it compiles, so it's really like front and center in your face, saying, "Hey."
Absolutely, yeah, that's right. Change it to an error. Yeah.
Should get red squigglies or something.
You'd think so. Yes, maybe. Oh, there we go. Yeah, that's right. Well, and here's the good thing as well, is that you can actually simply add the gating code straight away from there.
Yeah, wonderful.
That's so nice, yeah. And it also gets the name right and all that sort of thing. So now we've got that gated, and of course you won't be surprised to see that this will work.
Yeah.
The other interesting thing about this sample is you can show an app bar, and you can hide the app bar, and you can show it and this sort of thing. You can extend the view into the this plays with some of the Chrome, if you like.
That's one of my favorites.
Yeah, and you can change the color. Beautiful yellow. That's coded in. It's not. That's not kind of a default color.
Okay.
But actually, the phone version had a couple more things there. So this actually uses adaptive UI as well, because there's a couple more buttons there for the phone.
So let's
just prove it to you.
Yeah, let's view that again. I didn't notice until you said it.
No.
Yeah.
So let's run this on the phone.
So the last thing I saw was like the extended title bar and the title bar color. Oh yeah.
Set status bar background.
Yeah.
Set status bar hidden. There we go. You can set the background. You can change it. So there's some things, because the status bar is phone only, and this is so combining the two techniques. So actually, what I've got in here is in this project. I've got a custom trigger for device family. So this is an example of the device family trigger.
I see, yeah.
And then in the UI, I've got...
You've got a VSM, have you?
I've got a VSM.
In that visual state, you probably have that trigger.
Here's the visual state groups.
With the visibility.
Go away.
Ooh.
Here we go. So for device family desktop, we set uses this custom trigger. If the device family is desktop, then we set that bits to collapsed. So there you go. So that's kind of bringing the two things together. Right. Okay, so that was a demo of that. The other thing I mentioned at the beginning of this is that you can use this to call specific API versions. So you can also, the situation here is we've currently got 10.240 UWP out, and also the extension SDKs are kind of version 1. So down the line, or continuously and kind of at their own cadence, things are going to update. And we push updates. Now a lot of the dependencies on an app, like actually .NET Core 5, are actually local to the app now. They're shipped as NuGet packages. Uses NuGet packages and shipped with the app. So any updates if you change that, you just ship the new NuGet package along with the Windows Store normal update, which is just another app update. Some of the stuff are platform updates where the UWP gets upgraded and that sort of thing. But you're going to have this situation where for a moment, even though the user population is kind of moving on to, I don't know, 10.0.1560 or whatever, there are still going to be some users on 10.240. So you might want to offer up-level capabilities, perhaps, to take advantage. There's some new APIs in the latest release. So you can use the same technique for this.
That's nice.
And this one uses, is API contract present?
So actually, I think that sounds...
Well, yes, we actually just had a question
on this, so there you go.
So the question is, what is more correct, to use is type present or to use the is API contract present? And that depends what you want to check for.
Yeah.
Because the particular type might be present in different versions of the API contract.
Correct.
But if you're looking for a specific version, and the contract is the one that is defining the callable surface.
Yes.
And we will, we'll do minor updates of that, or we'll do major updates of that. So with this one, you can actually check the is API contract present. If that specific version is available, then you can call that version. I mean, you kind of know already that a type is in there because you know what's in that version of the API contract. Otherwise, you wouldn't have written this code. So then you can call the up-level API for those systems that have got it, and otherwise you can just fall back to maybe the original usage, usage of that. So I don't see you using this a lot, to be honest. But there's going to be
unless you know something very specific in a new contract that probably has a new API.
Yeah, that's right. So you're kind of coding very defensively, and you still want to have one version of the app package that's going to span different target levels of machines.
I can see it being a case where maybe the method exists on one version and the next, but the next version does something slightly different, and therefore you would use this.
Yeah, that's right. We've got a question on the performance implications of this. API information. Do these methods use reflection? Well, this is a runtime check, isn't it?
Yeah, it is a runtime check, so it would have to do some sort of
interrogation.
The overhead's really minimal.
It is really minimal.
It's not like it's going through a massive object tree.
So the trouble with reflection is you kind of have to load the type, and in this one the type's already there. It's more.
It's actually looking at the metadata. I think.
That's
I don't believe it's actually going too deep.
So we don't think there is that performance overhead. Right, now, actually, this next topic is not about adaptive code, but I'm including it because it's a related subject, which is it's more about the store and the packaging. This thing is, how about declaring limitations on where your app can run, which might be connected. Maybe your app is will only run if device family, I don't know, IoT, for example, is there. Maybe that's the only one it will run on, and your app has no meaning on the other platforms. So you're using these adaptive code. You're using Extension SDK APIs. Maybe you don't bother putting that gating code on if it's only ever going to run on IoT, although it's probably good practice to do so. So you can actually declare in your app manifest limitations on where your app can run. So first of all, and I've chosen 3 specific cases here. The top one, actually, if you do file new project, you'll find that the this statement more or less is in there, but not explicitly how it is 10.0 to 10.2.4. What it actually has is 10.0.0.0.
Yeah.
And then when you compile it, actually what it does is it goes off and looks at what version of the UWP your project is targeting, and it plugs the appropriate value in.
Yes.
If you've got a dependency declared on Windows Universal at all, which you don't have to. If you've said that though, what you're saying is this runs on all UWP device families, and but you are putting some min version limitation on that, and you've said, okay, I've tested it. It will work on 10.5. It will work on others, but I want it to if it's on future versions, have the behavior down. What's the word?
It's just basically making sure that you're backwards compatible and you don't start taking on new APIs that you don't know.
The system, a quirk. That's it. The system will quirk back to 10.5 behaviors, that sort of thing.
Yeah.
So, but that still means it runs everywhere. Now this one, because it's got a Windows Universal statement in there, still means it runs everywhere. But in addition to that, specifically and only on Windows Desktop, we've got a more narrow version limitation. So that one we're saying, yeah, still runs everywhere, but for desktop, this package, I don't want it to run on 10.0. It's got to run on the minimum version that it will run on is 10.2.
In this case,
yeah. Now the bottom one, we haven't got Windows Universal in there anymore.
No.
So that means no, this doesn't run everywhere.
You're very targeted.
This only runs on Windows Mobile, or this only runs if you had Windows.IoT. You know, it would only run a specific device family. So these are the sort of variations on this, and this is all really part of your app submission process. Not really about adaptive code, but you know there is a connection there.
There is a connection there.
Yeah. You can also declare package dependencies on specific API contracts. So. On specific extension SDKs that you're referencing as well. So that's also something you can put into the app manifest. All right, so that's the adaptive code story. We looked at obviously the compiler conditionals, which is at compile time, how you use a platform extension SDKs to add references to APIs that are in specific API extensions, then the adaptive code pattern for actually calling them safely and making sure that they can't be called on the wrong platforms. And then a little bit about API versioning and declaring some limitations on the packaging.
Yeah.
All right, so we're done with that. We're just going to take a very short break. And there's actually a change to the published agenda. And I apologize if people have been staying up expecting the next one to be data binding. Basically, because of a confusion and a mess up, and we've not got the right bits here, we're going to shift that one to tomorrow and instead talk about the app lifecycle next, which actually does tie on from what we talked about this morning, which was the page navigation stuff. Yeah. So we're going to continue that story and talk about the app lifecycle. And then we're going to come back with some more XAML performance and XAML tooling and then the web. So we'll see you in a few minutes.